Hello, myself S. Sasidharan, Assistant Professor, Mechanical Engineering, Muthaimal Engineering College. In this video, I am going to discuss about the design for manufacturing and product development. First one, purpose statement. To provide an overview of design for manufacturing and assembly techniques which are used to minimize product cost through design and process improvements. DFMA refers to designing parts, components, or products for ease of manufacturing. Someone asked what is the purpose of DFMA means. The answer is better product at a lower cost. The simplest example, two-wheeler tire. In traditional days, number of components incorporated in the tire. In modern days, minimum number of components incorporated in the tire. That is the best example. Next one, design for manufacturing. Definition. DFM is the method of design for ease of manufacturing of the collection of parts that will form the product after assembly. Optimization of the manufacturing process. DFA is a tool used to select the most cost-effective material and process to be used in the production in the early stages of product design. Example, you are going to make the product. First two things you can consider: choosing of materials, and second one, methodology. When you are used DFMA approach, definitely you will find quality materials with low cost and right methodology. Next one, optimization. The purpose of optimization is to achieve the best design relative to a set of prioritized criteria or constraint. Optimization is defined as the identifying best design by the way of conducting various experiments and comparing various solutions to achieve optimum value. Optimum value means favorable value. Optimization approaches: operational research, calculus of variation, control theory, decision theory, linear programming, etc. Next one, major DFM objectives. First one, estimate the manufacturing cost. Second one, reduce the cost of components. Third one, reduce the cost of assembly. Fourth one, reduce the cost of supporting production. Fifth one, consider the impact of DFMA decisions on other factors. The first one, estimate the manufacturing cost, which means input part information, a rough estimate, refined data, and report. And the second one, and third and fourth one, so important term, reduce the cost of the component and the quality decrease means that is not acceptable. Decrease the cost at the same time, maintain the quality also. The last one, major part, minor factors, choosing materials and methodology, and also remaining minor factors also consider while taking decision. Next one, design for assembly. Definition. DFA is the method of design of the product for ease of assembly. Optimization of the part system assembly. DFA is a tool used to assist the design teams in the design of products that will transition to productions at a minimum cost, focusing on the number of parts, handling and ease of assembly. Example, I am going to make the product. Then how will find the good materials and methodology? Then I am creating 5 teams. Then the 5 teams conducting different experiments and comparing various solutions to obtain the better materials and right methodology. So the assist of various design teams, the important role in DFMA. Next one, differences. Design for assembly, DFA, concerned only with reducing product assembly cost. Minimize the number of assembly operation. Individual parts tend to more complex in design. Design for manufacturing, DFM, concerned with reducing overall part production cost, minimize the complexity of manufacturing operation, uses common datum features and primary axis. Design for assembly and design for manufacturing are much closer each other. And assembly means assembly cost included, the assembly operation cost included, and manufacturing means part consideration and manufacturing cost included. Next one, similarities. Both DFM and DFA looks for reduce the material overhead and labor cost. So you know very well the objective of the DFMA, better product at a lower cost. That is a major objective. They both shorten the product development cycle time. Third one, both DFM and DFA looks for to utilize standards to reduce cost. The major similarities to reduce the cost of the material when assembly operation or manufacturing operation. Sequence of analysis. First one, concept design. Second one, design for assembly. Third one, design for manufacturing. And fourth one, detailed design. Concept design, which means concept design is an early phase of the design process. It comes under interaction, experience, processes and strategy. Interaction indicates it's a concurrent approach. How can you make the concept means they comes from 100, 200, 300 plus ideas. Design for assembly. Second one, design for assembly is a process by which products are designed with the ease of assembly in mind. And third one, design for manufacturing. Designing parts, components or products for ease of manufacturing. So major advantage, the better product at a lower cost. Detailed design. So detailed design is a complete description of the product. It means plans, specification, estimation are included. Detailed design will include 2D and 3D model also. When your company needs your design in the form of 2D and 3D diagram for better understanding. Next one, proposed design. The diagram proposed design estimate the manufacturing cost, reduce the cost of components, reduce the cost of assembly, reduce the cost of supporting production, consider the impact of DFM decisions on other factors, recompute the manufacturing cost, good enough acceptable design. When you are choosing DFMA approach means first one, design approval, and second one, cost consideration. First one, primary cost, secondary cost, assembly. Primary is the heart of the machine and secondary is the minor supporting elements, and third one, assembly. And DFM consider the impact of DFMA decision on other factor means using software, DFMA software, you should analyze the cost and other terms. Recompute the manufacturing cost, conducting various experiments and comparing various solutions. Finally, your design will be accepted. The advantages of DFMA: design for manufacturing and design for assembly or the integration of the product. Design and process planning into one common activity. The goal is to design a product that is easily and economically manufactured. And next advantage, 20% saving while choosing materials, 30% saving assembling process. It's a concurrent approach because integrate both design and manufacturing activity. The design engineer compulsory should know the manufacturing activity also, and the manufacturing engineer should know the design activity also because it's a concurrent approach. Next one, the heart of any design for manufacturing system is a group of design principles and guidelines that are structured to help the designer reduce the cost and difficulty of manufacturing an item. The following is a listing of this rule. So in the DFMA, the approach, concurrent approach, and the various team created to obtain the solution by the way of conducting various experiments comparing the solution. So it's a major advantage. First, concurrent approach followed in this DFMA. Next one, I am going to make the new machine. Then what are the factors I am consider? The first one, reducing the total number of parts. The reduction of the number of parts in a product is probably the best opportunity for reducing manufacturing cost. Less part implies less purchases, inventory, handling, processing time, development time, equipment engineering time, assembly difficulty, service inspection and testing. So reducing the total number of parts. Develop a modular design. So modular design is an approach that subdivides a system into smaller parts that can be independently created. While design your product, you can follow the modular approach means each part independently created. Any fault will be found that can be easily diagnosed. The use of modules in product design simplifies manufacturing activities such as inspection, testing, assembly, purchasing, redesign, maintenance, and service. So, modular approach, the fault will be easily diagnosed because each part operated independently. Next one, use of standard components. Standard components are less expensive than customer made items. The high availability of these components reduce the product lead times. Design parts to be multifunctional. Multifunctional parts reduce the total number of parts in a design, thus obtaining the benefits given in Rule 1. Some examples are part to act both an electrical conductor and a structural member, or heat dissipating element as a electrical member, structural member. So whenever you're making product, you're choosing material like multifunctional parts. Part act as an electrical conductor and structural member, or heat dissipating element and structural member. So your part must be a multifunctional activity. Next one, design parts for multi-use. In a manufacturing frame, different products can share parts that have been designed for multi-use. These parts can have the same and different function when used in different products. In order to do this, it is necessary to identify the parts that are suitable for multi-use. For example, all the parts used in the frame, purchased or made, can be sorted into two groups. The first containing all the parts that are used commonly in all products. So definitely you are going to make the product means the choosing of materials to be multi-acted materials. Next one, design for ease of fabrication. Select the optimum combination between the material and fabrication process to minimize the overall manufacturing cost. In general, fine operations such as painting, polishing, finish machining, etc. should be avoided. Excessive tolerance in surface finish requirement and commonly found problems that result in higher than necessary production cost. Design for ease of fabrication, influencing while choosing of materials. Avoid separate fasteners. Fastener is a hardware device that mechanically joins two or more objects. The use of fasteners increase the cost of manufacturing a part due to handling and feeding operation that have to be performed. Besides the high cost of the equipment required for them, this operation are not 100% successful. So they contribute to reducing the overall manufacturing efficiency. In general, fasteners should be avoided and replaced by using tabs. Note this. Fasteners should be avoided and replaced by using tabs or snap fits. Snap fits means is an assemble method used to attach flexible parts, usually plastic. Examples of fasteners: anchor bolt, buckle, button, cam. These are the examples of fasteners. Fasteners to be replaced by using snap fits. The plastic is the main content. So I conclude my speech. So I'm summarize the total PPT. First one, DFMA. What is meant by DFMA? DFMA objectives, methodology, and you are going to make the product means what are the factors you can consider. So these are the things discussed in this video. Thank you.